Thank you for joining today's HashiCorp Tools for Container Security Workflows webinar. This webinar is being recorded and the recording will be sent via email to those who registered within 1 to 2 business days. Joining me today is HashiCorp Senior Solutions Engineer Dan Fedick, HashiCorp Solutions Engineer Dmitry Gabrielov, HashiCorp Senior Solution Engineer Luke McCleary. In this webinar, we'll cover how modern container security and some of the HashiCorp tools like Packer, Terraform, Consul, Vault, and even Nomad can help simplify workflows. Lastly, please type your questions in the Q&A box and we'll answer those during our Q&A session at the end. With that, I'll turn it over to you, Dan. Thanks.
Well, hello, nice to meet. Thanks for joining, and I hope to, introduce you to some new concepts within HashiCorp tool sets, and just in general security workflows for your Consul, for your container workflows. Excuse me. So again, excited to have you here. This is a tough subject to nail down because there's so many vectors that we need to talk about as far as the workflows are concerned. I'm not sure if you've ever heard or read of our Tao of HashiCorp, but the first of the 8 keys of those tenets is workflows over technologies. So instead of just talking to you about technologies, which we definitely will, I wanted to go, hit this from a workflow perspective. So today, there's a lot of conversation about containers, container security, and that's what we want to cover today. Before we jump into that, I wanted to kind of talk about just the company in general. Who are we? We're a publicly traded company. We've got over 2,000 employees. We've got over 3,000 enterprise customers. And 200 of the Fortune 500 companies. And we're involved with a lot of the major mission critical organizations and companies out there, everything from e-commerce to health insurance to even the DoD. We're out there and we're helping to defend a lot of these organizations through good security practices and through good workflows. And the idea behind HashiCorp is that we want to be able to create common workflows across multiple cloud environments. And we do that with a suite of our managed services, or managed and unmanaged services. So we actually have a self-managed service for all of these applications. We have, HCP for Packer, Vault, Terraform, and Boundary, and for Vault, but I said Vault already. And then we have the open source tools like Waypoint and Vagrant. And I'll go over those tools in a second. But basically, the idea is we want to be able to provision, secure, connect, and run any application across any environment and have one common workflow to do that with. And we do that with tools like this, right? You've heard of the OSI model. HashiCorp has this concept of the multi-cloud operating model. So how can we use our tools to build common workflows across multiple cloud environments so that we can provision? So in our infrastructure layer, we have the ability to provision infrastructure across multiple clouds. So we can use our Terraform resources and our providers to provision instances and clusters and load balancers across all these different cloud providers, and do so with infrastructure as code. We can use Packer to build our AMIs for AWS, or our VMs, or our today we're going to talk about containers. We actually build Docker containers with Packer as well. At our security level, at our layer, we actually have Boundary and Vault. Boundary is our zero trust network access layer. Allows us to be able to provision services to a specific user based on their least privilege and based on the user's policy. So they've been authenticated and they're authorized to a list of services. And to access those services, we can inject credentials from Vault and dynamically generate those credentials on the fly. So you get short-lived credentials from Vault. So that's kind of our zero trust layer, security layer there. And if we go a layer up, we have our networking layer to connect all of our services together. And we do that with a tool called Consul, which is basically our global service mesh that allows a least privilege access between services. One more layer up, we've got Vagrant, which is one of our oldest tools. Vagrant is our tool to allow you to codify your development environment and be able to spin up your development environment quickly. Waypoint is a deployment tool that allows you to deploy to multiple endpoints, like single instances, your EKS cluster, your Nomad cluster, your Docker Swarm, all with one Waypoint deploy command. And then Nomad is actually our version, or is an orchestration tool that allows us to deploy containers and non-containerized workloads in a super scalable, very simple containerized tool, or containerized and non-containerized applications. So we can deploy Java jars and Python scripts and containers out into our Nomad cluster. And we can do so and scale out to millions of containers, thousands of servers. So very scalable environment. All right, and then so to kind of step back a little bit, securing the data center, securing our applications used to be somewhat simple. I'm old enough to remember that it wasn't necessarily simple, but it was simpler than today. We had this concept of a trusted perimeter. If you were on the outside of that perimeter, you were treated as a bad actor, a threat. If you were on the inside, you had trusted access to data. And most of the applications that were on the inside of that had to, to connect to those applications, you had to go through, your moat, basically, your one way, the stovepipe into the data center. And behind those applications actually were pretty static. So in order for us to get access to those, we would just put them behind a load balancer and set the IPs for the web servers that we were installing, or the middle tier servers that we were deploying. And as things have changed, we've expanded the boundary of the data center. Now we're working into multiple cloud environments. We have multiple orchestration environments. We're working with different identity providers. A lot more vectors in which data access can be revealed to our threats. And as we've changed, you can see that security breaches have really increased. So all these changes have brought in so many new injection points for threat that now we've got a real problem on our hands, right? We've had a 380% increase in data breaches in the last 2 years. 82% of those involved a human element, right? So it's somebody who maybe didn't automate something and it went wrong, and a data breach happened because of misconfiguration, for example. That 9 out of 10 of those happened because of stolen credentials. Maybe we had a PKI certificate or, database access or a token on our laptop, and the laptop was accessed by somebody else, and then they were able to get into a data center or a VPN, and then move laterally, and then infiltrate that data and exfiltrate that data. I'm sorry. And then 62% of those intrusions or those data theft breaches actually involve the supply chain, right? So now we're talking about, I'm just deploying software, and I'm deploying software that wasn't necessarily good software. Maybe it came from a bad actor, and that's not being checked. So I kind of want to talk about that in general and what those processes look like from a container perspective. So we've added in containers. Containers have become ubiquitous. We've added in multiple orchestration environments. If you're not using containers, that's one thing. But for the most part, if you're starting on the journey of containerizing your environments, it's definitely a lot of new things you have to think about, right? Just in general, threat vectors that could infiltrate your environment. We have just the authoring and building of your containers. You want to be able to sign your containers. You want to be able to push those containers to an artifact repository. You want to tag those those containers, validate those containers, scan them, run them. So these are all different places in which you're injecting a new process into your workflow. And there's some common pitfalls that happen when you go into containerizing your workflows, right? So first thing is it's cumbersome. Your build process is cumbersome, so you don't want to do everything manually. You want to make sure that you're codifying everything and that you're automating everything. One of the things that I started out with when I was building containers is I would build the containers out and they would be like a gig in size. And we definitely don't want that. We want to have the smallest container possible. In this case, we want to make sure that we have minimal containers with as least packages in the smallest size we can get out of a container. We want to make sure that we're not deploying containers that have vulnerabilities on them. So we want to do things like container scanning. We want to pull from verified repositories, because a lot of times you'll have unverified repositories or containers that are just out there you can just pull from. And we want to pull from, approved repositories. Maybe in your environment, if it's a highly governed environment, you might have your own container registry within the boundaries of your network, and you could use those ones. And those ones have all been scanned and signed. So that's a good way to go about using approved repositories. Security policies: before we deploy our containers, we want to ensure that we have some sort of runtime policy that we're checking before we're deploying our containers into our environment, or even uploading those containers into a container registry. And then once we have, and where are we getting those verified images from? The sources. We want to ensure that we've scanned all of unverified image sources, and that we've scanned and signed those containers. And I'm going to go over all of those steps and kind of like good workflow practices and good tools we can use along the way. Again, just to kind of walk through this container lifecycle, we're authoring your container, you're building that container, you're scanning the container, signing it. Maybe you're at some point you're encrypting your containers if necessary. You'd be tagging your containers, and you want to validate that container before it runs. You're obviously going to push that up to an artifact repository, and then you're going to run that container. And you could run it, on a single instance. You could run it on Docker Swarm or Kubernetes or ECS or Nomad. Nomad is, again, our orchestration tool. So the first step in kind of building containers, building out your Docker file. So a Docker file is very simple. It says, this is who wrote the file. This is the steps that for the environment variables that you want to pass in. Here are the run steps. You want to use a specific user. You put all that stuff into your Docker file, and then you'll go in and you'll do a Docker build. And then if you want to encrypt your container, you would do a Scopio encrypt. And if you want to scan your container, you could do a twist CLI scan. Twist CLI is twist lock if you haven't used that before. Or you'd use Prisma Cloud to scan your container. There's a bunch of scanners out there you can use. And then once you've scanned, you'd want to sign that container. And then once you've signed it, now you want to push that up to your different artifact repositories. And if you have different regions in which you pull from, you might have multiple regions that you push to. So that's a lot of steps that you have to kind of think about and codify along the way. So one of the things we can do is we can use Packer in this case. So from a HashiCorp tooling perspective, the workflow that we can, basically accomplish a lot of these steps with is using Packer. So Packer allows us to not only author and build the actual container itself, but we can also use post-process tools to scan and sign, and encrypt and tag, and then push those out to the different repos all in one Packer file. So this is really nice because we can have one common tool to do that all. And not only can we do that with containers, but we can also do that with our AMIs. We can do that with our VMDKs. So for example, you can see here, these are the different builder types. So you not only can, build containers, but you can also build all your artifacts for your different cloud service providers. Then you could add in different provisioning tools. So like say, I want to build a golden image pipeline. I'm already using Chef in other places for my configuration management, but I want to add it into my golden image. So there's a Chef provisioner, there's a Puppet provisioner, Ansible, there's a local shell provisioners if I want to run a bash script, for example. And then as far as post-processors are concerned, so I've built out my container. I can then run different post-processors to run afterwards. And I can say, I can send a message to Slack, or I can send, I can run a scan or a sign or an encryption. I can do all kinds of different things as a post-processing step to those builders, and then push those to different artifact repositories or different data sources after we've done all this. And if any one of those steps fail, the job fails, and then we can send an event out saying, hey, this failed, check in on this process. So that's some of the features of Packer. And you can kind of see here, this is, one of the features, this is something you can also do with just Docker files. It's the concept of multi-stage builds. But in general, we want to do minimal containers. So in this case, you can see like, if I had 4 layers or 4 steps within my process, the first step would be download the distro itself. Could be very small. If I'm using something like Alpine, I could have like a 7 meg Alpine image. Alpine, just a very small Linux distro. Then I can install Go, right? And installing Go, and all the build tools that come along with it. It's a pretty big install. And then I want to download the actual repository that I'm going to build. And then I'm going to do the go build command. And then I'm going to go, I have that artifact now within the container. And now I can run that, except for it's 650 meg, which is very big for something that needs to scale fast and to be able to move around at speed and to be very minimal in size as far as packages are concerned. So in this case, we can have a multi-stage build, and we could basically do all those steps, but only have 2 steps in the final artifact that we send up to our container registry. So we have the original operating system distro, and then we have our Go binary that's installed in there. So now we have a 13 meg container image that has very few packages and is very small in size. So say I'm running this in a Lambda, or I'm running this in a scalable function as a service Kubernetes system using Knative, or if I'm using Nomad, I can scale this up very fast, right? So it's way more portable. We have less packages. So if I'm scanning something, I have a lot less vulnerabilities I have to worry about, faster startup, and I have less to troubleshoot. Right, so that's building the minimal containers. That's one workflow that Packer can do as well. You can also do this with just your Docker file, but Packer can also do this as well as the things we're going to talk about here in a minute. So then we have image signing, scanning, encrypting. So we can actually use a post processor within Packer to run, after I've done the build, run the scan on that container. And once I've scanned that container and I know that there's no vulnerabilities, or at least the vulnerabilities that I want to see are not there, and then I can sign it saying, hey, this scan was done by this server or this user, and now we're going to push that up and push that up to our repository. One other thing that's really nice with Packer, so we actually have something called HCP Packer. So HCP Packer gives us an additional feature that's really nice, where we can do iteration revocation. So one problem that I ran into at my last company where I was doing operations is, we had automated this process, which is really nice. We automated a process. Every week, we would roll all of our clusters to the latest AMI, or the latest patches that were installed. And we'd roll those out into staging Monday through Wednesday, and then Wednesday through the rest of the week, we'd roll that out into production. And it would be a slow roll, but we'd get basically the most recent patched. Almost every week, we'd have a most recent patched Kubernetes cluster, or a ECS cluster, or whatever, as far as the operating system is concerned. So what happened though is that we ended up having hundreds of AMIs, and the same thing happens with our containers. You start automating this process, you start having problems with the automation, having multiple containers and multiple images out there. So from my perspective, I want something that's going to go out and revoke a lot of these images that are sitting out there, so I don't have old images with vulnerabilities sitting out there. So Packer gives you this ability to do image revocation based on time, or based on just if there's a vulnerable package in that container. Before I'm going to go into software supply chain a little bit, does anybody have any questions? Just drop in the chat if you have a question. I can answer those before we get moving on the next step here. Okay, so I'm seeing a question here. Our company's CI infrastructure is using Kubernetes. Can the Packer artifacts as code workflow be run inside a container? Yes, it can. All you have to do, just same with like GitHub Actions, you can download the Packer binary and then deploy that. Just the same as if you were going to deploy a GitHub action runner inside your Kubernetes environment. You would be able to deploy that in that manner as well. Okay, so software supply chain. So just kind of an introduction, because supply chain management is kind of fairly new. I'm working with the DoD a lot, and this has become a big conversation within the DoD, but a lot of the commercial world hasn't really seen this as something they need to deal with yet. However, there is a reason to use it. So if you think supply chain, the first thing I think of is like a device, a computer, a phone, and all the different components that are in that device, right? And if we want to work with an environment that's has high governance involved, like healthcare or healthcare or DoD or insurance. We have a lot of governance that needs to happen. We want to make sure that all the packages that we're deploying out into our environment we can trust. We have something called attestation. So we can attest to who's actually made changes to that software supply chain. The same way as if I was building a device, I want to make sure that the person who installed that memory into that device was a badged employee at whatever company that we have approved that is allowed to install that memory, and that we're not installing additional chips into a hardware device. The same thing goes for the software supply chain, right? We're using all kinds of open source. No matter who you are, you're probably using open source somewhere, and we need to be able to attest and scan all of those different pieces of software, whether you're writing it or you're borrowing it from an open source provider based on the open source license. So if you can see here, there's a little tweet down here that. I think a couple months ago, I saw this tweet out there and it made me think. But he said, I'm uncovering what seems to be a massive, widespread malware attack on GitHub. Now, I don't know how far this went or how true it was, but the idea is that basically over 35,000 repositories were infected. Crypto, Golang, Python, containers, everything, had this attack on it. And the idea is that if I am a third party and I want to inject malicious code, all I have to do is pick up one of these Ruby gems or Python libraries or containers and inject some malicious code and then upload those for download for the open source community to download. And with supply chain, the idea is that everything that we commit, whether it's through a Git commit or a Docker container, we want to ensure that we have a verified signature on those commits. And those verifications should be able to be, we should be able to attest to those. And we want to make sure that we're only using approved sources for our containers before they're getting deployed into our orchestration systems. So in order to do that, we can use things like, there's an organization called SigStore. They're an open source company that has built a bunch of tools around the supply chain. And they've built something called Cosign, which is container signer, basically. So you can interact with Vault with Cosign and say, okay, I'm going to sign this container before I push it to my artifact repository. I've scanned it. I'm going to sign it. I need a key that proves that I am the person who I say I am. So I log into Vault, for example, and I can go access that key and then sign my container registry. I could use a PKI certificate, a short-term PKI certificate, to sign that container as well with Cosign, just the same as I could sign a Git commit. I could use Git sign, which is also a SigStore command, as a part of my GitHub committing workflow, and I could sign that, and then I could be able to attest to who actually committed that signature. And then you could actually take those signatures and store them in something called Fulcio. So it's called Rekor, R-E-K-O-R, which is not our tool, but it's a SigStore tool that basically allows you to create a public ledger that you can then go query and then attest to the generation of those certificates and see what part of the process, was a scan completed, who was the person who signed this, at what point did they sign, at what time, and what organization are they from, all that kind of stuff. So using SigStore and using Vault, we can create certificates or create keys to sign our containers before we're deploying them or pushing them up into our artifact repository. Another thing we can do is we can actually validate that signature before it gets deployed as a gate check into our container environment, right? Whether that's container Kubernetes, whether that's Nomad, Docker Swarm, whatever, or we're just pushing it out, using Terraform. We have all these different gate checks where we can validate that signature it comes from a validated source, right? So you can see here this post-processor script is a part of the Packer build. Packer is reading from Vault that key that's going to sign the certificate, push it up to the artifact repository, and then again, you can, from a container perspective, from the orchestration perspective, I can read the key out of Vault, then validate that is a approved person, and then deploy my container onto my orchestration system. So you can kind of see there's a lot of play here. In this case, we have Packer, we have Vault, we have Nomad, we have a lot of different tools for the workflow for the containers. So if you don't know much about Vault, I'm just going to kind of go into that a little bit. Vault is an identity-driven credential store. So I can store or generate credentials, act as a broker for a bunch of credential types. And I'll go into that in a second. But the idea is that I want to be able to log in a Vault. I have authentication methods, whether I'm a human or a machine. So if I'm a human, maybe I'm authenticating against Active Directory. So I'd say Vault login Active Directory. And it would push me off to my Active Directory, sign in with my CAC or sign in with my MFA. Then I would be given access to Vault. That Vault access assigns you to a policy, and that policy assigns you to a list of paths within Vault. So if you can see here, this process here, there's 3 types of clients within Vault. There's the HTTP API. So you can query it, if you're writing with HTTP binary library within Ruby or within Python or Go, you can use the HTTP API. If you're on the command line, you can do, Vault read, Vault login. And if you're in the UI, you can just log in at the UI. That will bring us to our auth methods, assign us to a policy, and then give us access to secrets engines. So a secrets engine could just be, a regular secure key value store. It could be a database credential management tool. So in this case, just regular secret storage. We could actually have dynamic generated SSH keys. We could do dynamic generated PKI certificates. We could do dynamically generated database. So we actually act as a broker for a database to create user accounts for those databases and create, short-lived dynamic credentials for that database as well. And we manage lease revocation and secrets and all kinds of stuff. So Vault is a very powerful kind of central tool that's used throughout the data center. If you haven't used Vault already, I definitely, feel free to ask me more about that later, and we can kind of go into, more detail. But this is how we're using it with containers. We can actually store our keys with Vault and then retrieve those keys and then be able to test those keys out based on the PKI certificate. The next step, whoops. I don't know if I can escape here. Okay, so container policies. So again, I've kind of talked about this, hit on this. Before we deploy into an environment, we want to ensure that we have a policy that's codified, and we are able to, check that policy before we deploy out into the world. So there's a bunch of ways to do this. One way is to use Terraform, and Terraform has a tool called, well, actually all of our enterprise tools have a language called Sentinel, which is a policy as code language. We have it sitting in front of Vault, Terraform, Consul, and Nomad, so you can actually create policies that allow, access to ACLs or access to, or check certain things on, cloud resources like an S3 bucket. Is this S3 bucket allowed? Does it have a allow all or a public facing S3 bucket installed? Is this AWS instance, encrypted or not? Like, there's a bunch of things you can check before you deploy your infrastructure. Also with Nomad, you can do the same thing. You can write all your policies and codify them before you deploy your applications into that Nomad cluster. Same thing with like a Kubernetes admission controller, right? You can check these policies using some sort of policy agent. In this case, for us, we use Sentinel, but we also, Terraform specifically, can integrate with things like Open Policy Agent and Sneak and Packer and Bridge Crew. So I'll kind of go into a couple of these here in a minute, but we can check before we're deploying infrastructure, before we're deploying our containers out into the world. We can check against these policies to check, is it encrypted? Is it signed? Is it scanned before we deploy it? Does it come from an approved source? There's a bunch of things you can check. Matter of fact, I think I wrote some of them down here, right? So does it come from an approved repository? Is this an approved golden image from my repository? Only allow scanned containers that have, no or very little vulnerabilities, based on the incident levels. Are they set up from assigned approved identities? Are your containers running as non-root users? One thing you want to do also before you deploy, especially in a production level environment, you want to have a minimum set of replicas, and maybe your service, you want to have what's called a pod disruption budget, right? So these are all container level policies you can check. Are these containers labeled with the correct labels? There's a bunch of things you can check from a policy perspective before they're deployed out into your orchestration environments. Another thing that's really nice with Terraform is we have this integration with Packer, where we can actually check to see if a Packer container image, or an AMI for that matter, is verified and actually has been validated without any vulnerabilities before it's been deployed. So I can set an enforcement level at advisory or mandatory to say, like, if there's any vulnerabilities, do not deploy this into our environment. Or if it's maybe lower, it's not a Sev 1, it's not a critical vulnerability, then just do an advisory and you have to come in and check on it. But you can actually fail the deployment before you deploy that into your environment. Right, so you can see here, there's an example, data source validation results. We had a scan result, and the scan resource was revoked, so we can't deploy this out in your environment. Please change your image that you're going to deploy with. This is really helpful. This is just another example of a gate check that you can use before with policy as code before you deploy your infrastructure, whether that's a container or any infrastructure for that matter. But in this case, we're talking about containers. And last but not least, we have what's called Consul. Consul, again, is our service mesh. Consul allows us to connect our containers together, our services together. And in our orchestration environments, they're containers, but we can also reach outside of a containerized platform. We can install a Windows application and register that application with Consul. But what happens is we basically we allow all of our services to be injected into the Consul service mesh. And then we create access control lists or intentions between all of our applications. So if you think about a developer, the developer is going to want to, he's going to know, or he or she are going to know what services are going to be able to communicate between each other. And we don't really want to have access outside of those services. So we should only have a set of, so your web server and your database server are allowed to connect to each other. Well, we want to set a very direct communication line between them. So we use a proxy between those two different services through the service mesh to control that proxy and only allow access to, authenticated and authorized services. So we have mutual TLS with least privilege between all of our services that are in the service mesh. So Consul is very powerful as far as like managing the connections, the network between all of your containers. So it's just another way that you could have a threat vector where we're managing with a HashiCorp tool. So I think that's the last. So in this case, I just kind of want to review some of these containerized workflows. We're authoring our containers, we're building our containers, we're signing our containers. We might be encrypting our containers, pushing those containers, tagging them, validating, scanning, running, and actually connecting, which I didn't mention here. And we're doing that, and we can use a lot of these tools and a lot of features of the HashiCorp toolset to work throughout these different workflows. So that's all I have today as far as using HashiCorp tools and the secure containerized workflows. I'd love to ask or respond to any of these questions here. I see the first question. I'll answer to anonymous anon attendee. What is the recommended way to get credentials into Vault? We've debated pushing them into Terraform, but are interested in if there's a more appropriate way of doing it. That's a great question. Depending on how you're using Terraform, I can answer this question one way. But if you're using Terraform Cloud, or if you're using Terraform Enterprise, the secrets, basically you can have variables in your Terraform. And every variable in your Terraform you can set to sensitive. Now on the back end, it's actually Vault Transit Encrypt. So you're actually using Vault on the back end if you're using the secrets engine or the variable secrets in Terraform. So if you go in there and hit sensitive, it automatically saves those credentials into a Vault backend, basically. If you're not using Terraform Cloud, you could use Terraform. You'd have to use a local shell provisioner. There's a way around it where you can actually call Vault from the binary perspective and Vault login, and based on the authentication of where that Terraform runner is running. So then you'd be able to log into Vault there and then access those credentials. The same as if you're using Chef or Ansible, you would basically break out to a shell to call the CLI or use the HTTP API within Terraform. So I'm not sure if that answers your question completely, but we have built in Vault as kind of the backend for all the Terraform Cloud and Terraform Enterprise products. And then Gia, you asked, does Packer have the ability to do vulnerability scanning of an image? Okay, so Packer is not the scanner in this case. So Packer can run a shell to call a bridge crew or a sneak or any of these container vulnerability scanners. So Packer is kind of the language that does the calling of those things. But both Packer and Terraform at different phases of that container can do vulnerability scanning. So, but you have to integrate that with that vulnerability scanner itself. If that makes sense. So in this case, if we're using Packer, we've built the container out. The first step in that, so after you've built it, the next step would be a post processor. You'd use that Packer post processor to then run that scanner. And then you can push it up to the artifact. If it fails, then it would fail the job and it would never get pushed up to the endpoint. And if you're using Terraform, you could actually integrate. So Terraform Cloud actually uses both bridge crew and sneak and a couple other policy agents and scanners as a part of that process. And you could actually do that scan within Terraform, which is really nice. And then there's an integration with HCP Packer, Terraform and HCP Packer, that'll allow you to only deploy verified scanned container images, which is super helpful. So with Terraform Cloud, there is actually, I might be able to show you, there is, if you go to the section where it says run tasks, you'll actually see the run tasks there. One of the run tasks that you can choose from is Sneak. I think one is Bridge Crew. One is Packer. So you can actually choose HCP Packer there in the run tasks in Terraform Cloud. Awesome. So we had a couple questions for everybody. How familiar or how far down the path is everybody with containerize? Are there a lot of people just starting out? Are there a lot of people that have, been doing container security and they're just more, just looking for the security aspects of this and already using, heavy into Kubernetes? How many of you specifically haven't started on containers and are working to build that process out? I don't know how that works here as far as checking for answers, but I don't see, okay, well, I don't see any answers here, so maybe I can't ask and get answers or questions answered here. Oh, okay. So it looks like in the chat section, you can ask, the first question I had was, are you using containers today? So you can answer in the chat here. And if the next question is, are you using HashiCorp tools today? It sounds like some people are using Terraform. I'm not sure about Vault, but it sounds like Terraform is one of the tools being used. My last favorite question to ask a bunch of people in this world is, are you Vim or Emacs? Which is less of a question these days now that everybody's using VS Code, but it used to be my favorite question to ask. Feel free to answer or ask any of those or answer any of those questions here in the chat. Also, just kind of a note, I wrote about this in a Medium article. You can go to tinyurl.com/container security. So if you're interested, this is kind of a good takeaway. There's not just HashiCorp tools in this. This is like all of the tools surrounded all of those workflows. So this is a pretty good article on, actually, there's two ways to get to it. I think container security. This one's the Hacker Noon one, but it's all written out here with all the different container tools that we use and all the things you need to think about from a container security perspective. So I'll add that here as well if somebody's interested.
Awesome. Great. Well, if nobody has any other questions, we'll go ahead and wrap it up. So thank you everyone who submitted questions and who joined. And we thank you today, Dan, for this great presentation, and Dimitri and Luke for being on call. I hope everyone enjoyed today's webinar. We'll make the recording available after processing, typically within 2 days. We'll send an email to everyone who registered with the recording link, and it will also be posted on the HashiCorp YouTube channel. Thanks again and have a great day.
Thanks, everybody.